the landscape is constantly changing. It's really like basically a full-time job just to keep up with all the tools and all the models and all of the usage of those. And I'm going to do my best to show you what I recommend, the kind of my reading of the pulse of the field and how you can apply it to your own work. But a caveat is this could change tomorrow, right? So this is like a snapshot in time of like where things are right now. Okay, so first I want to explain like my perspective of where we are with AI. So there's been rapid improvements in, what's important here is it's not just the LLMs getting smarter, it's also the tools built around those LLMs getting smarter, which makes the whole system more and more capable every day. And it's reached the point where I really believe that maximizing our impact as neuroscientists requires us to become experts in these tools because they're just so powerful that it would be really hard to be just as productive without using them. And this means two things. One is using these tools to accelerate the development of our analyses and of the analysis tools that we build, and also building AI tools that facilitate scientific discovery. Right. So the great thing about this is you can use the tools to build more tools and kind of work in a feedback loop. Right. So it's a matter of not just blindly using an LLM, but building software infrastructure around that LLM so it can actually be useful. So that's kind of abstract, but this talk will go into exactly what I mean by that. Ideally, you would do both of these at the same time, right? You would be using the tools to accelerate your development, and you would also be building better tools that can then, of course, help you build faster and more accurately. So I'm just going to give one slide here on kind of the history of LLMs and the state that we're in right now. And it's about the scaling law of LLMs, because I think this is really central to the whole situation that we're in right now. So large language models, abstractly, they are machine learning models trained to predict the next character. Now, okay, they're trained to predict the next token, which is somewhere between a character and a word. All of that's kind of details, right? Like the implementation detail. And I would say really what it's trained to do is next character, and a token is just kind of an implementation detail. And so that's all it's really doing. You present a string of letters, and then it predicts the next letter. And what they found is that if you just throw more and more compute at it, more compute, higher data sets, more parameters, the error that you get on that next letter prediction just goes down and down and down and down. Right? That's the key finding here. And that is, but note these are logarithmic scales, so you really got to throw a lot more at it. But if you do that, the error will go down and down and down. And the key thing is here, you reach a point where it's not just doing a simple, you need to close this parenthesis, or knowing how to spell a word. To get the next letter, if you keep on going down this error, you need to do some very complex reasoning. You need to be able to do math. You need to be able to know historical facts, right? In order to predict the next letter of a sentence, you need to know scientific facts. And so just as a consequence of going down this curve, these machines get smarter and smarter in emergent ways, where now it all of a sudden can do mathematical operations that it was not trained to do. So that's basically the origin of all of this. And then the performance of these systems can be tracked using a number of different benchmarks. So we're good at predicting the next character. We can now answer questions. We can now write code. So let's figure out how good it is at doing these things. And so to understand how good these AI models are, all of these different benchmarks have been developed. The MMLU, the Massive Multitask Language Understanding, is like a huge multiple choice test across 57 subjects. Then that was started to become too easy. So then we have doctoral level scientific questions. Also, can it actually solve real GitHub issues as a software engineer in a closed environment? And then an interesting benchmark here, the chatbot arena, is where users present a prompt, two different models produce a response, and the user pick which ones they like more. So that's a really cool benchmark because it's like impossible to game. Well, actually, it is possible to game, but it is harder to game. And it produces an ELO score which is like chess. So they're basically playing each other like chess, and the user picks which one won. And so then you can rank all the models against each other using the score. So you end up with these this huge collection. This is just 4, but there are dozens of these different benchmarks testing the different capabilities of the models. And it gets to a point where it's just like really just cumbersome. I mean, you know, how are you supposed to check against 50 or 60 different benchmarks? So there are efforts now to aggregate across these benchmarks and give a composite score. So my personal favorite right now, artificial analysis. This is basically where I go to get like an overall intelligence score of a model to get a sense for like how they stack up against each other. And they have a formula for like, okay, well, it's 10% this and it's 10% that, basically aggregating across these different benchmarks. Now, there have also been other types of ad hoc benchmarks because I think people are worried that that any one of these could be gamed. Like you could just train a model to get better and better at that. Even if the questions haven't been leaked, you can still run an evaluation of the model against some very similar type of test and then steer the model towards being very good at that specific thing and not necessarily good at general work. So there are all these other like ad hoc tests that people do. So one is to ask the model to produce an SVG of a pelican riding a bicycle. So this guy, Simon Willison, has become kind of an influencer in the LLM space. So here are early attempts at doing that, pretty awful. And then, Sonnet 3.7 it's not really a pelican, but at least the bicycle is clear. Okay, DeepSeek R1, sort of. And then you get into these, the previous generation models that started to look decent. Now this is Fable. So here we are. We've finally done it. We've produced a recognizable pelican riding a bicycle. And so this has kind of become a meme. And of course, this is doing it with an SVG, but you can also use image generation models. So here, this is one of my favorite uses, I think. This is maybe one of the best uses of image generation, is asking ChatGPT to create an image of a horse riding an astronaut, where the astronaut is riding a pelican that is riding a bicycle, and it looks very chaotic, but they all just manage to balance on top of each other. And there you go. So this is the image to beat. Maybe the SVG generation will get here one day, but until then, I think this is maybe symbolic of the state that we're in with AI. I don't know. Yeah, at least there's pizza. Why are you like this was not in the prompt, by the way. The AI just decided to put that there. Maybe it's trying to communicate something to us. I don't know.
You said it has to be very chaotic but balanced.
Right. Yeah.
Trying to say that.
Okay. So this is a plot that was, I mean, it's pretty old at this point, but the purpose of this plot is to show that the models are getting smarter, and that open source, open weighted models have been closing the gap on closed source models. So the closed source models are getting better and better, and so are the open weighted models, though lagged a bit, as you would expect. And here's an analysis, again, a bit old. I couldn't find a more recent version of this, but the trend has been continuing. So this is taking this is finding what's the cheapest model that can perform a certain minimum score on the MMLU. And what we're finding is that cheapest model is going lower and lower in cost, right? So, and this is again on a logarithmic scale. So this is okay, so it's a score of at least 42 on the MMLU. That was ChatGPT 3, cost $60 per million tokens. But then that very quickly went down. And then I guess here we're at, maybe 5 cents. So from $60 down to 5 cents. to achieve the same score. And then if you bump that score up, you see a similar type of decrease, this very fast decrease in the cost to get a certain intelligence. So yeah, there are models that are very expensive right now. The models are getting more expensive, but also to get the same intelligence is getting cheaper, right? So don't be distracted by the fact that, well, both, I would say both observations are important, right? Because you want access to the state-of-the-art models, but at the same time, the intelligence is becoming more accessible to more people. Okay, so all of these are kind of benchmarks that aren't necessarily neuroscience related up until now, right? They're general coding questions. There are some doctoral questions. They may have included neuroscience, but they weren't concentrated on it. So this is a paper that was really exciting to me, and it tested specifically how well these models could do, again, on neuroscience questions. So basically what they did here is they took old models and newer abstracts from recent real scientific papers. So the models could not have seen the abstracts because they were released before the abstracts were ever released. And what they did with the abstracts is that they took out keywords like increase or decrease, like keywords that are central to the findings of the paper. And then they replaced that with like bracket increase / decrease. And they told the model, pick which one of these. It's a 50-50 shot. Pick which of these words is correct, right, in these abstracts. Now, this is a tough question because these are new abstracts, so they're presumably new scientific knowledge that the community isn't aware of, right? But you could maybe use prior knowledge of neuroscience to have a better than 50% shot of getting the right answer. So they collected a bunch of these abstracts. They did this manipulation where they took out the key finding and they asked experts in the field, neuroscientists, to do this task, and they also asked LLMs to do this task. So what they found for the humans is that across basically all levels of career status, they did about 60%, so slightly above average. They were above chance, but not much, right? But these were new abstracts that they may have not read the papers. Okay, so understandable. And this is true basically for every subfield as well. These, by the way, are really old models at this point. I mean, this paper is, they used open weighted models because they did some manipulations later in the paper that required open weighted models. And this paper, this analysis was done a long time ago. So the models that we have now are way better, but these did 80%. They beat the humans across the board in figuring out which of the words was correct in the abstract. And again, these are like really dumb models by today's standard. And that was true of every subfield. The LLMs were able to answer the questions better than the people. Okay, so this is interesting to me as a proof of concept. Yeah, Arvind.
Yeah, I find these results very funny. I'm definitely interested in reading this paper, but you can infer a lot just by sentence structures and not really have to know anything about neuroscience.
Yeah, but the humans could have done that too.
Yeah, but that's what I'm saying they're doing, because there is no difference between any part of training. That is kind of bizarre, don't you think? A pre-doctoral student, assuming they have no knowledge in neuroscience, if they're doing. If a pre-doctoral student, like take a high school, not a high school, maybe like an undergrad student who has no experience in neuroscience.
You think they could achieve this 10% just by inferring from the
sentence structures, yes.
Okay.
Which means that, because I would have hoped to see some improvement as training. If that's not true, then what? That's just funny.
In training of the people.
Yes. It's panel C, which is why panel A and B are suspicious.
I mean, okay, but even if you are not very interested in the pre-doctoral students, I mean, you could look at just the faculty, right? I mean, you could just focus on this bar, right? The point of the paper is that the LLMs are able to perform better than neuroscientist experts. So ignore all the other bars and just focus on this one if you don't if you don't like the other bars.
No, I like the other parts. They exist for a good reason.
Yeah.
Which is why it's surprising. It may be just English.
We should ask the predoctoral students for advice.
Yeah.
More often.
Right.
Yeah, a faculty is as good as pre-doctoral students. So.
I think it could be also related to the fact that like abstract in general, like also recently are quite stereotype structure. So maybe like pattern recognition is just
I mean they tried to make it so that you couldn't infer the word from the context. So like, increases or decreases, like in some cases it's just not clear from there like whether it would be increases or decreases. Like so like, inhibition of this cell type increased activity in this other cell type in this brain area, or decreased. Like, how are you going to be able to infer that, right? I guess I should have included like an example, but that's the general gist of it. Yeah.
But it is, I agree with that. That's what I also noticed. It is very weird that you don't see any, I mean, the question is there something weird about the task, right?
Yeah.
And this suggests that there is something weird about the task, because there's no way that a pre-doctoral student and staff has the same level of success rate, right? I mean, isn't it weird, right? It's I mean, if you assume that the academic staff has been gathering information and has some repository of knowledge, there should be some effect on the accuracy.
I also find that surprising. Yeah. It's not the aspect of this that I've been focusing on, because I'm more interested in like, wow, the LLMs can do so well, and it's better than humans can do. That's the idea.
But it's tied, right? If the task is skewed, then maybe the task is better.
Maybe it suggests that the task is there's something wonky going on. Yeah, I mean, I encourage people to look into this and dig into it further. I mean, I guess I'm taking these results at face value, but I haven't dug into the data myself. Yeah. All right. I think we can still take away from this that the LLMs know a good deal about neuroscience. Okay, so then how do you actually use these LLMs? So I think probably everyone here has used it as a chatbot. So I'm just going to go over like what a chatbot is. So basically, what I said before is that the LLM predicts the next character, and so all you really need to do to build a chatbot is to put in a system prompt, right? Say, you are a chatbot assistant with general expertise. Be helpful and don't misbehave. Now, the actual system prompt for like Claude is really long and elaborate. Basically, this is what it says, but in like a lot more words and a lot more guidance. But this technically is a chatbot. This is like your kind of MVP of a chatbot, minimum viable product of a chatbot. So then you could put in a transcript. You could say, user, help me write a report. Assistant, sure, what's the report about? User, panda bears, and then assistant, PA, and then you just fill in the next letter, right? This is an LLM under the hood at work as a chatbot. Fill in the next token, but still. This is really great for learning about something, testing an argument. I mean, it's able to really draw upon all of its knowledge and really give you more information or test your ideas, drafting or editing an email. You'd be surprised if you're not using this on a daily basis. You'd be surprised about how good it is at editing, how much it knows. I would really recommend using it in this chatbot mode. I use it every day. I use it all the time. Whenever I have a question about science or about cooking or about like planning a trip somewhere, like it's very knowledgeable. Though I will say there are some things you need to watch out for. One is hallucinations. So, I mean, you're all aware of this at this point. It's been like all over the news and stuff. But I want to talk about hallucinations specifically in the context of like the work that we do, and a trap that you can easily fall into. So, if you have it write a passage and cite and put citations in that passage, it will generate citations. It will generate references to papers. And what I've found is that sometimes those papers don't exist. And this can be really sneaky because it will, like I was generating something on like brain-computer interfaces, and it referenced Georgopoulos, who's like a famous brain-computer interface, like monkey motor researcher, who's one of like the the leaders of that field. And the date was around the peak of Georgopoulos' career, and the title was like basically talking about motor neurons and their tuning, and it was like totally the type of thing that lab would publish. And it was a made-up paper, right? It never existed. It could have existed, but it didn't. And I'm like pretty familiar with that field, I didn't catch it because it was like, yeah, okay, this person on roughly this date published this paper, checks out, but it was wrong. It didn't exist. So I would say like it's just these hallucinations can be very sneaky. So you just have to be really careful with that because they're very plausible. And if you ask the chatbot, is this real? It'll be like, oh yeah, it's real, even though it's not. So that's part of the reasons why we need to do things like, well, we need to know the limitations of these systems, and we need to build software around it to prevent them from making these types of mistakes. Also be aware of the training date cutoff. So all of these models, they're released at a certain time, and then they don't change after that time. That might change in the future, but currently, like it won't have any idea about what happened in the news yesterday, unless it was released yesterday. But even if it was released yesterday, the training cutoff is before the release date. So you need to be aware with any model that you're using, be aware of the cutoff date of that model, and just know that all of the information it's giving you is only up to that time. So if there's brand new changes to software or advances in scientific knowledge or current events or anything else, it won't know. The third point to watch out for is agreeableness / sycophancy. So OpenAI kind of got into this at one point. So they trained their models, and they were kind of hyper fixated on the approval of the user, like how much the user liked the response that they gave. And what they ended up training was a very sycophancy is a bit of a vocab word for the non-native English speakers. It just means it's like flattering you. It's just overly complimentary. Where it's like falling over itself to compliment you. So it was this problem where like the bot was just agreeing with every stupid idea that you proposed to it, and potentially causing a lot of harm because it was agreeing with things that you could harm yourself. So just be aware that is a potential downfall. I think they've sorted out that, and I think all of the model makers are aware of this, so it's become much less of an issue now, but it could still crop up. Okay, so you can work with it to access all of the advanced knowledge, but can it actually code? So if you want an AI to code, you can use the chatbot. You can just say, give me the code for a function like this. That's okay. I mean, you can make progress that way, but it is not the way that I recommend having AI code, because you have to do so much manual labor, right? You have to describe it. You have to, put it in the chat window. It produces a response. You copy and paste that into the right spot. You run it. There's an error. You copy the error. You put it back into the chatbot. The chatbot says, oh, okay, now here's the corrected function. You copy and paste it back. It's a lot of manual work. But all of that can be automated by an agent. So I'm going to talk about what an agentic harness is, like really from the first principles. So I showed you this context window for the chatbot, really as preparation for this slide, because in an agent system, all you really do is you modify this system prompt to tell the LLM that it's able to call certain commands. So it's able to do things like prompt the user, but it's also able to do things like search the web, or edit a local file, or run a local file, or search the file system, or you can give it basically any operation it wants. And then what it does is the LLM will just do its LLM thing and predict the next character, right? So you'll say, help me write a report, and then the assistant now will issue the command user prompt because it has other things it can do, but it'll say, sure, what's the report about? Panda bears. Okay, now the assistant, instead of just immediately responding, it might decide that it'll call the search web tool. and then it will get results about panda bears. It will understand how to read those results, and then it will start writing a response. So basically what this shows is that on the LLM side, all it's really doing is generating the next character. But by using this system prompt, we can inform the LLM that it has the ability to use tools, and then we just parse the output of the LLM for invocations of those tools, and that allows us to basically give this LLM the ability to do whatever we want it to do, whatever abilities we want to give it. So it's like chatbots, but we have the added ability to call tools. So you can extend tokens for reasoning. You can search the web. You can search, read, and write local files. You can run commands on the command line interface. You can, of course, prompt the user in the chat. You can launch sub-agents, or you can have the agent indicate that the task is finished. So these are types of commands, but really it's like any command you want as long as it can be implemented programmatically. So at the heart of it, agents, they're kind of a complicated concept, but also they boil down to just two things. There's just two things that a system needs to be an agent, in my opinion. One is that the LLM is given instructions that allow it to call tools. And then the output of the LLM is parsed to call those tools. And two is that it can operate in a loop. So the LLM can decide to search the web, and then the results of that web search are passed back into the LLM without intervention by a user, right? So it can decide to run a function, and then the output of that function is passed back to the LLM without needing to involve the user. And then so it might do a web search, pass back to the LLM, write a function, see the error, pass back to the LLM, edit the function, write back to the LLM. So it all is in a loop. And so this is a screenshot of a YouTube video describing one of the agents called Klein, which is the first agent that I really got into. And it shows how all these pieces fit together in real life. So you start the task, you make a request to an LLM, and then the first thing that happens is it uses Git behind the scenes to save its state, so you can always rewind, which is always a nice thing to do. And then it loads in the environment details. So you've got the system prompt and any custom instructions, such as the current open files, current open tabs, working directory. So this is something that integrates directly into your IDE, so it has information about that IDE. And then it has your conversation history. So all of these are loaded into the context. So system prompt, custom instructions, and then all of your previous conversation, including the reading of any files that it's done. That is passed into an LLM, which with Klein, it's kind of model agnostic, so you can plug in any model you want, whether it's Claude or Grok or ChatGPT or Gemini or DeepSeek or hundreds of other options. And then it decides between a set of actions, right? Attempt completion means it thinks it's done, or execute a command, replace in files, search files, read file, list files, write file, call an MCP, which basically is an expansion pack for this, right? It allows you to give the LLM more actions it can do, or do actions in a web browser. Then the output of that command goes back into Klein, and it's repeated again, over and over. And one of these is prompt the user, one of these potential actions. But there are also lots of other potential actions it can take. Now, in terms of actually, let's talk about what agents are available. So I talked about Klein. So what's the current landscape of agents? So all of the major LLM providers also have associated agents. They all do this. They all do exactly what I just described, with slight deviations in what types of tools they call, how they manage sub-agents, what the system prompt is, advice about how to do coding properly, et cetera. But at the end of the day, they basically follow the structure that I described. It's simply injecting things into the system prompt and then building a loop where you interpret the commands of the LLM. So Anthropic has Claude Code. This is my current daily driver. OpenAI has Codex, which I've used and I've been pretty impressed with. Gemini has anti-gravity. I haven't really used it, but it's basically like a similar type of thing. There's GLM Z code. This is the latest and greatest open source model, which is much cheaper than the others. There are also model agnostic harnesses. So these are harnesses where you can use an API to just access any model you want. So these include Cursor, OpenCode, KiloCode, Klein. There are a lot of these that are open source. So if you're passionate about that, you can use. I think OpenCode is pretty popular right now. I for a long time used Klein and was very happy with it. Now the actual interfaces that you use you've got a lot of flexibility, right? There's lots of different types of ways that you can actually the user interface for interfacing with these agents. Claude code is traditionally done on the command line. So you just open up the terminal and you communicate with it that way. That's a little bare bones for a lot of people. There are several of them, including Claude Code, that have VS Code extensions. So there is kind of a chat window, and then it interacts with VS Code, which is a popular IDE. And so you can actually monitor the code that's being changed as it's being changed. All these major ones also have like standalone apps that you can download and double click and chat within the apps. There are also web interfaces, so you can just go to a URL. You don't have to download the apps yourself. And then a lot of them also have GitHub integrations where you can treat them as a GitHub user, or there are some other interface where you don't even have to download an app or go to a separate website and it's just straight in GitHub. So this can all be confusing, how like these different types of ways of interacting with these agents map onto the evolving agent landscape. But I would just say like they're all very similar, right, in terms of their capabilities. So just pick one that makes sense to you in terms of your workflow. Like try a few different ones and see which one makes sense with your workflow. I think most of you will probably like VS Code extension integration if you're already using VS Code. I personally use command line, but I don't have a very good reason to justify that over VS Code extension, other than I like to run like 10 agents at once and it's easier on the command line, but I don't know if I'd recommend that. I think that you start to go insane, so I don't know. But any one of these would be fine. Any questions so far? Ryan, would you mind getting me a glass of water? Thank you. Okay. The model landscape is constantly evolving. I had to change this slide 2 days ago because OpenAI released their new state-of-the-art model, and that had to put that on here just to show how it stacked up. Thank you so much. And I will admit I spent a decent amount of time trying to keep up with like what are the latest and greatest models and what are their capabilities. So this is a chart where the y-axis is that intelligence metrics that I mentioned earlier from artificial analysis, where this is an aggregate score over all of the official benchmarks to give you one score that gives you an idea of the capabilities and intelligence of a model. Now, of course, you're dealing with their weighting of the different benchmarks, which has some judgments about the balance between knowledge and codability and stuff like that. But I'd say it's pretty reasonable. And then the x-axis here, this is interesting because they're not just showing you the cost per token. Now, that's one way to measure the cost. But here they're showing the cost per task of a certain I actually don't remember what task they're doing here. I think it's like the software engineering task. But some of the models are much more verbose than others. So even if it has a lower token cost, the actual effective cost might be higher. Yeah, Jake.
This is the cost based on what the company hosting model is charging.
Yeah.
But not the cost of it. Not all these companies are necessarily. Most of them right now
are running at a loss.
Cost is artificially low.
Yeah.
All of them are going to be doing that at the same rate.
Right. This is for you using the model. This is not. Yeah. This is I.
The actual economic or environmental cost per token or per task, and like how that is predicted.
I have seen stuff like that, but I don't have that in this talk. This is really about like how to use these. Yeah, but that's a good point. Don't infer from this that this has anything to do with the cost that it actually costs the companies, be that financial or environmental. Yes, Oliver.
So, looking at this graph, right, it looks like GPT-5.6, Claude Opus, Claude Sonnet, they're all not that far away from Fable.
Wait, let's get Mike over there, if you don't mind.
All right. So looking at the graph, right, it looks like Claude Opus, Sonnet, even GPT-5.6, right, are not really that far away in terms of the performance from Fable, but are quite a bit lower in cost. What has been your experience since you've been playing around with this a little bit, at least more than I have, between like what Fable gives you versus what the sort of, cost benefit, I guess.
Question. Yeah, that's a good question. So I'll say first of all, the GPT 5.6 Sol, this was released like 2 days ago. So the dust is still settling, I would say, and I haven't had a chance to like explore rigorously the difference. But yeah, you're highlighting a very important point here, right? Look at the difference in the Y direction between these two. It's almost nothing, right? There's just 1 or 2 points difference here. And in further still, going down here, down from Fable to Opus 4.8, there's not a huge difference. But there's a huge gap between the price, right? So if you're more cost conscious, you might say, well, ChatGPT 5.6 is probably the way I'm going to go because it's way cheaper and it gives you like, almost the same performance. That's exactly, by the way, the message that they put in their release notes, right? They were all about, look how much more cost effective this is for almost the same performance, right? They released like a bunch of charts showing that that's the case.
Just a quick question about Fable. Did you manage to run on something about neuroscience? Because for me, it's always so I have
comments
biology
on
or whatever.
Let me give my take on these models, and then we can do a round of questions. So Fable 5 is the strongest model right now, but it's very restrictive and it's very expensive. So by restrictive, I mean, so if you're not familiar with this backstory, it's kind of interesting. Anthropic released a model called Mythos, but it found so many security vulnerabilities that they decided they couldn't release it to the public because bad actors could use it to hack all sorts of systems. So they said, well, we have it, but we're not going to release it for everyone. We'll only give it to a few security companies and security teams so that they can find and fix all of these bugs. And that they did that for a while, and then they came out with Fable, and they said, okay, well, Fable is basically a little, it runs a little classifier first. If it is anything to do with bio or cybersecurity, then your query will be routed to Opus 4.8, and you'll be billed for Opus 4.8. But if it's not, we can let you run it on Fable. It's not going to be dangerous. And so now for the past few weeks, we've had access to Fable in this weird, limited, restricted way. And unfortunately, even the word neuro counts as bio. So as soon as it sees neuro, it's likely to switch you over. So you're going to have a hard time getting Fable to work on any of your projects. Now, if it doesn't, it's not like it just fails. It just downgrades to Opus 4.8, which is a great model. So it's fine, but you're not going to be able to really explore the benefits of Fable. I've only been able to use Fable really on side projects where I've been really impressed with it, building out full stack applications in a matter of hours. For my pet interests about dancing and app building and stuff. But when it comes to actual work, I've been trying to use it. Occasionally, it will go through if I I've carved out projects that don't say neuro. So I was interested in building a MATLAB library that reads ZAR v3. There just isn't anything out there right now there wasn't anything in pure MATLAB that did that. And so I just told it hey, look at this Python library, copy it into MATLAB, build a bunch of tests that go back and forth between writing and reading Python and MATLAB ZAR files and support all of the codecs and write good documentation and make it easy to install. And I was basically did that. I worked on that for like a day or two, and then it was basically done. And that said nothing about neuro, and it said nothing about cybersecurity. So it was able to go through and use Fable, right? So but you do, like, I would say a small portion of the work that I do, I can actually carve out to be Fable compatible right now. OpenAI 5.6 Sol, almost as smart, much cheaper and faster. This might be your current best option, though I haven't really used it. Anthropic Opus 4.8 is still my workhorse. It's great, honestly. Google Gemini is really trying. Their 3.5 model, it's lagging a bit. But they're calling this Flash, which means that they have a pro model that they haven't released yet. So they're kind of teasing that they have a much more advanced model. So we'll see, maybe in the next week or two, we'll see them kind of become competitive for the smartest model. If you're into the open weighted stuff, GLM 5.2 is really impressive. It's right here, and it's almost as good as Sonnet, and it's much cheaper. So if you're budget conscious, or if you're really into the open side of things, I would recommend checking out GLM 5.2. Okay, any other questions? Jake?
Do you have a sense of where on that y-axis is good enough for a coding agent? Like,
Yeah.
You've been very impressed with Fable, but like going from Opus to Fable, like what really is the qualitative difference to see, if any, in terms of how well it does it?
So the question is, what's the real practical difference between Opus and Fable? Like, what's the?
Just in general.
Yeah.
Going from
right.
a score of 50 to 60 on
Yeah.
the scale. What does that do?
Okay, so I would say it's the higher level stuff. So Sonnet 5 and even Sonnet 4.5, back when that was here, was perfectly good at writing syntax, right? It knew how to write syntax. Opus 4.8 is better at making decisions, but it's not perfect. But it will, if you tell it, oh, do it this way, Opus 4.8 might say, well, actually, that's going to cause a problem down the road because of this. Like I don't really know, like I'm more of a neuroscientist. I'm trying to build apps. Like I might make decisions that would cause scaling issues in the future. Opus 4.8 would say, well, you could do it that way, but like this is the canonical approach for that, right? It'll help you make decisions. And then I would say Fable 5 just goes further in that direction, where you're able to give it much more high-level guidance of just like, make an app that does this, and it will just make the right decisions for you.
I've also noticed that Sonnet, with bespoke bugs that are like not really common problems, doesn't create a procedure to debug software well. What needs to be done in order
and then exit as well.
Damn.
Sonnet gets, pardon me. Yeah, no, Sonnet basically gets stuck at more complicated debugging issues, whereas Opus it's like almost like a longer term future like perspective.
Yeah, yeah. Pulling out details in long passages. They just are getting better and better at that. I mean, I wish I had like a concrete. Well, I tried this with Opus and it didn't work, and I tried it with Fable and it did work, but maybe next year I'll have like solid benchmarks. But that's just my impression. This is not working anymore. Okay. Oh, my computer's frozen. Great. Funny. Let's exit the page. One second. Now let's just I'll show you how I use it in action, okay? So I'm gonna be like honest about what I really do day to day. So I might discuss a problem with software with the team. Now, almost all of my meetings are on Zoom, and I have a system called Fathom, which you can use for free, which records the meeting and records a transcript of every meeting. And so now I have a transcript that I can pass into an LLM if I want to. Next, write a GitHub issue. That GitHub issue I might pass the Fathom transcript to an agent and say, write an issue based on this problem that we discussed. And then I'll just vet it and it'll post it. Or I'll manually write the issue, or someone else has written an issue. I'll open up Claude Code in Terminal, in the repo, and paste the URL of the issue. And I might also include a Fathom transcript if there's important conversation about how exactly we want to approach this problem. I'll discuss the solution with Claude Code. If you use the word plan, it will enter a planning mode, and it will intentionally ask you specific questions about how you want to approach this problem. And it will spend time creating a markdown document of exactly what it's going to do for you to review before it acts. If it's a simple issue, you don't need to use planning mode, but if it's something that requires some decisions, you probably should. I have a Claude Code write all the code, all the tests, and draft a PR message. And then I work with it iteratively, solving any issues that I identify. I review and approve it. It posts the PR. It tags Claude Code in it. And then it is reviewed by the team. And then as soon as I see a review that requires an action, I again paste the issue into Claude Code. It can see the entire conversation of the issue, and it can respond to any comments. This works well for me. I know this is a lot for many of you. Like you're not this deep into it, but I'm just telling you what I do, so you can kind of you make the right decision for yourself. But I have a $100 a month subscription for myself and for everyone on the team at CatalystNeuro, and this is the type of workflow that I do and I recommend on my team. Okay, let me show you what that looks like. So I have identified this issue. Now, this relates to the issue conversation. This is a good issue. It doesn't have all of the ingredients that I mentioned in the good issues talk, because this is Alberto, and he is the lead developer of NWB Inspector. So he doesn't need to say, hi, I'm Alberto. He knows this is more of a documentation type thing. But it explains exactly what happened and what type of solution that they want, and it links to other issues. So this is a really nice example. So this library is NWB Inspector. Basically, it has dozens of checks that are run against every NWB file that's posted on DANDI to see if they're following best practices. And every time we see a systematic issue with NWB files on DANDI, we try to build a check to prevent that from happening in the future. So here's a really good example of this. If you have video files that you have a Windows computer, you might end up with backslashes in your path for that video file, but we want them to be forward slashes, just like the Unix system in NWB. So we want to be able to flag that if anyone has a field that's referencing an external file where that field is using backslashes instead of forward slashes. All right, so this is an issue. It has not been resolved yet. I see this, I think, great. This is something Claude can definitely do. So I'll copy this. I'll open up my terminal. I'm in NWB Inspector. I'll say Claude. Let me make this bigger. Okay, here's Claude Code. I'm in Fable, but I think it might demote me to Opus 4.8 because there's something neuro-related here, but we'll see. All I need to do is just paste this issue. I don't need to do some kind of fancy prompt engineering. It'll understand what it needs to do. Yep, it demoted me. So we're using Opus 4.8, but that's fine.
Like the rate of approval that you use. The level of approval that you use, like in this session, about like the amount of manual command accept that you is almost zero for this type.
Okay, so here we go. It just asked me for approval. Yeah. So I have it being able to read anything on GitHub without my approval. Otherwise, I'm just constantly approving.
So like a good idea could be like reading everything and then like for writing.
That's what I have. Although honestly, if I'm doing a side project or like a one-off, I'll just use a mode called dangerously skip permissions. They call it dangerously skip permissions, and then it just never asks me, and it just goes and does it. So it uses the GitHub command line tool called GH, and it can install that for you. And you just run some authentication, and essentially it'll like bring you to the web interface. You log in, and then it'll just have the ability to act on your behalf. Okay, so it wants to write this check. Now, I know you guys are not familiar with the NWB inspector library, but essentially we need to register the check, define it, say what neurodata type it refers to, create this doc string, reference the best practices document, and then, okay, this is good. So if there's no external file, just move on. If there is an external file, iterate over them all, decode them if they need to be decoded into string, find a backslash, and if it exists, tell the user, hey, this should be a forward slash. Yeah, Jake.
There's just tiny, minor personal preferences. Like,
yeah.
I prefer my F strings to have a single hot single.
Yeah. So you can write a claude.md file, which it will read every session, and that's a good place to put your style preferences. Yep. You just say exactly as you told me. Yeah. It also, this library read files before writing. So it already knows, like, this is not standard Python, right? This line. So the only way it would know to do this is to see all the other checks that we've written and realize, oh, okay, I also need to do that.
So Ben, while you're in here, how much ability do you have to sort of inline edit what it provided you?
Yeah, I don't edit, but you can talk to it. So here, right?
I wanted to change the error message. Then you basically have to reject the entire thing.
You can say, so you can press tab here, and you can say, change the error message to have an exclamation point.
You can only edit through English.
Yeah.
Yeah, got it. Yeah, but at least you can
and then there you go.
Yes, but.
Yeah, so there you go. Yes, but, and then it added an exclamation point.
Okay.
Now this is important. It's adding import paths. It's not just creating the check, right? It's actually integrating it into the entire library. So what it needs to do is write the check, write documentation around why that check exists, which it's doing now, do proper imports, and write tests. So it's to be able to do all of this without me telling it to do that. So this is the documentation. It's writing in the change log, which is correct. Now the tests. It's importing the new check into the tests file. Okay, and then this is a great thing to show. So I know a lot of you probably don't write tests, but this is a really good practice, and so I want to show you like that how to write tests and that the LLM is doing a good job of this. So first, it's writing a convenience function here to make an image series. And then basically you want to write these little functions that check all of the conditions of the function that you just created. So generally you'll have like 3 or 4 or maybe even more check functions for each function that you write. Yes, Estrella. Oh, can we get a square back there? Nice catch.
Why are you using the terminal instead of the graphical user interface?
I don't have a good reason for it. I like to run multiple of these at once, and I find that easier in the terminal. That's my reasoning. But honestly, it's great in VS Code too. There's no reason not to do that.
Okay, thank you.
Yeah, I'm just showing you how I use it honestly. So this is what I do every day. Yeah. Yeah. Yeah, I don't. Yeah, I would probably recommend for most people to just download the extension in VS Code and do it that way. That's how I started. That's kind of the gateway into agentic. And then when you fully embrace vibe coding, you're just like running 10 agents and, drinking a lot of coffee. Yeah, Kathleen.
When you say you're running multiple, do you just like multiple terminals?
Yeah, just open a new tab. And then, it gets tricky when you have 2 agents running on the same repo. But if you are doing different repos, it's totally fine. Just yeah. You really have to worry about AI psychosis at that point. You just monitor yourself. Yeah, Carter.
I'm curious, have you done this demo on this issue?
No.
So have you done anything multiple times where you evaluate how consistent
Yeah, last year I did this on a different, it was also NWB Inspector, and there was one issue that I just didn't ever merge any of the solutions so that I could keep on using it as a demo. And then the one time it failed was during this talk. But I'm confident that it's going to do right this time. Yeah.
Did not specify in your markdown that you have to have a change log and it reside in the test?
I don't know. Let's look. We might have a Claude MD file here.
It might be in your .github, but it might be in your personal one.
Oh, yeah. Yeah. So there are levels of instructions. I think I have edited my own thing. Look for a changelog file. If it exists, edit that before you submit a PR, like those types of things. So you might have to do a little bit of hand holding just for styling. Okay, back to the checks. So it checks that a proper...
one more question.
Oh, yes.
How do you review the results of agentic coding?
Yeah, I'll show you.
Okay.
Yeah. So it checks that a proper external file works and doesn't throw anything. It checks that if the external file is missing, that doesn't throw anything. And it checks that if you indeed have an external file with backslashes, it will throw the proper error. It also tests different types of strings, which can get tricky in Python, whether it's a byte string, because H5Py, depending on the version of H5Py, it can return strings in different ways. So it's knowing that it needs to be able to handle that. Basically all of these checks check out. So this is my first passive review, is I'll just read it as it's writing it and steer it. But of course you need to do a final review, right? Okay, it's running the tests to make sure that they run. Now again, this is running the tests, and then the output of that is going to be fed back into the LLM, and it will iteratively fix things. So, okay, it found an issue. It found that the starting frame to match the number of external files. Okay. So it found an error, it fixed it, and now it's running the tests again. And it could just do this until it works. All 14 tests pass. Now it's probably going to run the full test suite. Check fires on the \path, not the forward slash. Run broader. Okay, yeah, it's running more tests. Okay, it says it's done. Now I can say branch, commit, push, draft, PR. Yeah, I'm slowing it down for you guys. Draft PR. Okay, it's telling me what the commit message is going to be. I don't really care. It's usually really good at writing commit messages. All right, draft PR is up. Okay, it correctly links to the issue it's going to close, summarizes, explains its decision for the severity of the check, which we may debate, exactly what it changed, how it tested, and then it added a little generated by Claude code, which I think is only fair. And then the CI is running, which runs all the test suites across different versions of Python and operating systems to make sure nothing very subtle has broken in some specific deployment that we want to support. And here are all the files that are changed. I can go in and review these. I can, at this point, if I decided I wanted an exclamation point, I can say like add and now I probably would just edit this myself, but just to show you, I can comment this, and I can do this on my own PRs or on anyone else's PRs. If I go to the conversation, I'll see this. I can copy the link to this message and send it here.
I have a question while doing that. So, like when your PR was on github.com, it just said your name, but then on like the home screen for that repo, it had some like old commit that was like then.
Yeah. Yeah. Right, because it's a matter of signing the commit versus the account that submitted the PR. So the signing of the commit is both. So in the Git history, it's both, but in the GitHub history, it's just me. So yeah, it's a little confusing, but it ends up being kind of a mix of the two. Okay, so it was able to read that comment and re-add the exclamation point, but I'm just going to say no. But you get the idea. So you can use this to review someone else's PR as well, and to respond to reviews. And honestly, this is basically perfect, basically a perfect solution to the issue. I haven't like rigorously read every line, but I've basically read everything, and this is basically exactly what I would do. But it's like nearly instant.
I will say it is when you, in terms of sort of the habits, right, that we have. You talk about writing good issues.
Yeah.
I think having the note saying, "Hey, this was generated by the AI."
Yeah.
And then also saying, "Hey, I reviewed this," right, and confirm that that I signed my name to it is really useful for me as a developer.
Right.
Because I will get PRs that someone just completely AI generated, right? And they said, "Oh, it fixes my problem," but they didn't even look at what it did, right?
Yeah.
So now at this point, I'm basically the guy talking with their AI, right?
You also have to be really careful about doing this with external projects, right? Like I wouldn't be so cavalier. Like I am doing it now, like with internal projects where we're like part of a team, and somebody like on my team can know, they're like, hey, your AI screwed up. Like, let's close this. Let's think of another solution. But you really don't want to. I know there are developers out there. I've heard developers talk about being just snowed with dozens or hundreds of PR, like sloppy AI PRs, and you definitely don't want to be contributing to that. So just be a lot more cognizant. Like something I did recently is I did go kind of out of my depth on a PR, and I wrote at the top like, hey, this is AI generated. I did my best, but feel free to close this if this is just noise for you. You know, just be understanding that is like it's something that the developers are dealing with.
So personally, for me, I think the best practice that I've been using is I will leave a PR in draft mode until I've done a formal review of it, right? And then I say, now I'm opening it up for review for the other person. Right? So that it's still me signing it and having my name attached to it and not just,
exactly.
go off the AI. Because, there's always things that are going to happen. And if I, now the developer, and I'm indirectly talking to your AI, it just creates a lot of problems at that point. But, it's an extremely useful tool.
Right.
And for some of you, sort of an early entry point drug might just be also Copilot, right? Because you have in GitHub a little button that says assign to the agent, right? And it will go off and create these PRs and do things. Or do even once I've, when I get PRs, I might assign Copilot to do a review. That's also very useful.
And just to add to that, I think most of you, if not all of you, have access to GitHub Copilot Pro through your education, through their education partnership. Like you sign up with your email address, edu email address, and you get GitHub Copilot credits. And then once you have signed up, you can have Copilot review your code and help write code in VS Code and elsewhere.
Yeah. All right. I'm already over time, and I've got a few more slides, so let me just get quickly through the rest of this content. Okay, so let's say you want to expand the agent's capabilities beyond just what it can do out of the box, which is already a lot. But there are two main ways to do this. MCPs are they're model context protocols. This is a bit of an older approach. Basically, it provides a programmatic interface for agents to call like any tool that you want. You can think of it kind of like a REST API for agents, if that's helpful for you. It just basically allows the agents to call any tool. The problems with it, though, are that it takes up a lot of context and just like define these tools that the agent may not use. And then it doesn't allow for programmatic control, so you couldn't easily do it in like a for loop. Like you have to call the agent. If you want to call something 100 times, then you have to make that call 100 times, which is just using up a lot of tokens. So because of that, the field has really shifted towards using skills. Now this is like actually way simpler because it's literally just markdown files in a folder. It's slightly more complicated than that, but not really. You just explain it in plain English and in code snippets. This is useful for if you have repeated tasks or really niche knowledge that the model doesn't already have. Basically, this is analogous to docs. These are essentially docs for an agent, like they're docs specifically designed for an agent. And often the best way to create these is just to create them directly from docs, right? To take all the docs and just say, turn these into a skill, and then that will put them into markdown files that are really efficiently read. The great thing about skills is they're loaded progressively as needed. So you wouldn't load the entire skill into context. You would load the first kind of indexed file, and then that can point to other files, and those can point to other files, which are read progressively as they're needed by the agent. The gotcha here is that using the snippets of code requires you to give your agent the ability to execute commands on your computer. So I'm, of course, comfortable with that. As you've seen, it's already been running commands on my computer. It's ran PyTest, but that's something that, depending on the computational resources you have available, that may not be an option for you. We have a collection of Claude skills for CatalystNeuro that is open. We have one for analyzing DANDI data sets that tells AI how to like stream data sets efficiently from the archive. We have one for building extensions. We have a really extensive one that we're working on for converting data. So this skill MD is the parent file, and it describes a 9-phase system for converting data: experiment discovery, data inspection, metadata collection, synchronizing, code generation, testing, developing notebooks, uploading to DANDI. All of that's covered by this skill. It's not finished yet, but it's something that we're iteratively building as we're trying it out on different conversions and finding and fixing edge cases. But this has really changed the game in terms of our efficiency in converting new data sets. Yeah, Oliver.
And as you're writing these skills, what in your experience is the biggest difference between writing a skill for an AI versus writing business documentation for a real person?
There isn't a whole lot of difference between writing it for an AI and writing it for a person. It's really going to be a matter of the iteration is much faster, right? Because you can say something and then you can have an agent try to do it. You can find the bug. And then there's a lot of like steering, I would say, in this, right? So I'll give you an example. Okay, yeah. Critical rules. Never, in all caps, assume you have all information. Always ask when uncertain. I wouldn't word it that way for a human, right? But you being like rude and direct and all caps never is really helpful when you're talking to agents. So that's an example of a difference, but like it's subtle, right? I mean, this could be given as docs to a human. It just wouldn't be the nicest docs ever.
This meeting starts at 9 a.m.
Exactly. Right. Oh man. We don't really have time for this, but so there was a really amazing blog post by the Anthropic team where a Harvard professor used Opus to try to do scientific research, doing some function approximation. And basically it was a project to try to see how Opus could be used as a research assistant. And the outcome essentially, he said he was able to do in 2 weeks what would have taken him 1 or 2 years previously. So it was like a 10x acceleration on the research, though it did require him to break down the project in very discrete steps and catch a few assumptions that were incorrect that the model made. I mean, it wasn't like 100% automated, but there's a blog post here that goes through like how he used it as part of his scientific discovery process that I found really inspiring. And I've been testing this out on neuroscience problems. Like I can say that it's pretty faithfully able to do simple analyses, common analyses like PSTHs, cross correlations, and regressions. It knows how to use common packages like scikit-learn and stats models. It can program routines like bootstrapping statistical tests. You can use skills to make it perform even better. So you can use niche packages that may not know about, like Pineapple, and it can give it information about how to efficiently, for instance, search the DANDI Archive using all of those different search tools. The issue is right now it's not always good at high-level decision making. So like it is able to write the code, but when it comes to actually translating between that and scientific knowledge, there's a gap. So it might say that one condition is higher than another condition without running a proper statistical test. It'll just like take the median of both sides and it'll be like A is higher than B. It's like, well, that's not very scientific. Then you tell it, can you please run a proper statistical test? And then it will run the right statistical test, but it just didn't make the decision beforehand to run that test, right? So you're still needed as a scientist to give your judgment and say and tell it exactly what kinds of routines to do. And I would say that it's much better at software engineering than it is at data analysis, primarily because the iteration is much clearer in software engineering. Either it runs or it doesn't, usually. Like if there's a bug, it'll just mean an error in the code. And so it can iterate itself. But when there's a problem in data analysis, often it just means you have a plot that looks like totally wonky and like way different than you expected. But then you have to use your judgment as a neuroscientist to understand that that plot is wrong and why it might be wrong. And those types of high-level judgments right now are, I don't know if they're beyond Fable because I haven't been able to run it on neuro stuff. I think they're beyond Opus 4.8, so we're still needed to like actually look at the plots and tell the AI what's wrong. I have this project that I presented at SFN last year, looking at reproducing foundational findings in neuroscience. So I just gave the AI a really simple prompt, like demonstrate reach direction tuning in data from DANDI Archive, with a skill that told it how to access data on DANDI. And it was able to completely autonomously generate these figures from real data and generate real results. So it was able to do that for direction reach tuning, for auditory frequency tuning, for orientation selectivity, for the visual system, for hippocampal place cell selectivity, and for directional tuning during reach planning. So these kind of foundational findings, now that our studies now are building upon these findings, they'll look at like different types of contexts and different types of training and different types of tasks that assume that these properties exist. So we're kind of past these as a field, I would say. Like they're not novel in any way, but these demonstrations show that the AI can find relevant data on DANDI. It can write relevant code. It can adapt that code to a specific data set, and it can generate plots that demonstrate key findings. The open question now is whether LLMs can actually help us with novel research. I would say this is not that the work I've done so far does not indicate one way or another whether that would be possible. And so I'm really looking for partnerships with neuroscientists who are able to do what that physics Harvard professor called a G2 problem, which is a problem that is novel in the space. It's not merely reproducing a known finding, but it's something that where we have a concrete end in mind of like exactly what we're trying to accomplish, like good approximation of a certain function that hasn't been approximated, that type of thing. And so I'm interested in finding a similar type of problem in neuroscience and seeing how we can most efficiently and effectively use AI to solve G2 problems. So if anyone's interested, I'd love to talk about it. All right, and that's it. Thank you all. All right, you've all been very engaged, asking tons of questions during, but okay, Juan, go ahead.